Hi, welcome to section 11.6, the area of segments and sectors. For our homework, we're going to have, it's on page 539 to page 541, numbers 5, 6, 9, 14, 15, and 20. So the first thing that we have to do is we actually have to talk about the vocab that we're going to have here. So our first vocab word is the area of the sector. Area of a sector is something that we've already talked about. It's going to be the arc measure over 360 times the area of the circle. So here's what it looks like. If we have a circle, the sector is kind of going to be like a slice of pizza. So it's not going to be the area of that whole circle, it's just going to be the area of a piece of the circle. And that piece is determined by the arc measure over 360. Now, the area of the segment. First thing I'm going to draw is a picture of what a segment looks like. A segment is actually part of a sector. It's a part of the sector that's bound by the chord and the part of the circle contained by your sector. It's almost like the crust of the pizza, if you will. The way we're going to find the area of that segment is we're going to find the area of the sector, and we're going to subtract out the area of that triangle. So let's actually try some examples. So for our first one, what we're going to do here is we're going to find the area of that sector. So the area of that sector is going to be the arc measure over 360 times the area of the circle, radius squared pi. So that reduces to give me 1/6 of 144 pi. 1/6 of 144 pi is going to end up giving me 24 pi. So now my second one. For my second one, what I want to do is I want to start off by creating that triangle. So here we go. We're going to find the area of the sector, and then we need to subtract out the area of that triangle. So here we go. The area of the sector, arc measure over 360 times the area of the circle, radius squared pi. So that's going to end up giving me 1/3 of 225 pi. 1/3 of 225 pi is going to be 75 pi. Now, the area of the circle. Now, the one thing that we know about this circle is that it's going to have an isosceles triangle built in here. All radii are congruent. If my arc measure is 120, so is my angle. Now, we can't find the area of that triangle here because we have to have a height. So the next thing I'm going to do is I'm going to drop my height, which of course is going to bisect my base and form a right angle, also splitting that 120 degree angle into 60 and 60. I'm going to take one of those triangles and I'm going to pull it out here. We have that radius of 15, that angle 60, my 90, so my other one's going to be 30. If across from my 90 is 15, across from my 30 is 7.5, so across from my 60 is 7.5 root 3. Now, for my full base, if 1/2 is 7.5 root 3, my other half is 7.5 root 3 as well. Area of a triangle, 1/2 base, 15 root 3, times my height, 7.5. Half of 15 root 3 is 7.5 root 3, and 7.5 root 3 times 7.5 is going to give me 56.25 pi. Sorry, 56.25 root 3, excuse me. Now, all we have to do is subtract this. Now, I know it's not overly pretty, but what we want to do is we want to actually leave this as 75 pi minus 56.25 square root 3 is my final answer, unless it says to round it. So here we go. Here's my next example. I want to find the area of the shaded region. Now, before I get started on this, I want to have a game plan for what we want to do. Now, when I look at this, what I actually see right here is I actually see a half a circle, and here would be the full circle. We have half of a circle up here that's shaded, and we have a center piece taken out. Same thing happens here. On the bottom half here, I have another half of a circle, again with a middle piece taken out. So I'm going to refer to this as my left circle and my right circle. both of which are going to actually be semicircles. So here we go. We want to count the units that we have. 1, 2, 3, 4 units for this top blue wave that we have here. 4 squared pi is 16 pi. Now, we're not talking about the full circle here, we're just talking about its half. So I'm going to chop it in half, and I get 8 pi. Now, that would be if everything was shaded in here. But as we know, not everything is shaded in here. I have a half a circle that I have to take out of that. So here we go. That circle is 2 units. 2 squared pi is 4 pi. That would be for the full circle. We don't have a full circle, we have a half circle. So I want to cut that in half, so I want to subtract out 2 pi. That left circle is going to be 6 pi. Now, the nice thing is when I look at this right circle, it's 1, 2, 3, 4 units as well. The circle that we're taking out is 2 units as well. So my right circle should end up, my bottom circle should be matching as well. So all I have to do here is combine my 6 pi, which would be this wave, which is just this top half. My bottom half is going to be the exact same thing, 6 pi as well. And when I add up 6 pi plus 6 pi, I end up getting a total of 12 pi. So here's our next example. We want to find the area of the shaded region here. Now, I want you to press pause and come up with a game plan, and let's see what we got. There's a few options for what we want to do, so although you might come up with something different, it might be okay. Press pause and let's see what we got. So here's what I would do. What I would do is I would draw in another radius. All radii are congruent. Since my arc here is 240 degrees, I'm left with 120 degrees. And if my arc is 120, so is my central angle. My game plan here is I'm going to find the area of this kite. And I know it's a kite is because radii are congruent, and because of our 2 tangent theorems, these segments are congruent as well. I'm going to find the area of my kite, and then I'm going to take out the area of my sector. Now, if you had something different, that's a-okay as well. So here we go. First thing that I'm going to want to do here is I'm going to want to try and bisect my 120 degree angle, forming 60 and 60. Now, we know that where that tangent meets the radius, we have a right angle. So I have a 30, 60, 90 triangle being formed. Same on my other side. So here we go. If I know that I have a 30, 60, 90 triangle being formed, what I'm going to try and do is I'm going to try and find the length of my diagonal. Now, if across from my 30 is 10, across from my 90 is going to be a total of 20. That's going to be diagonal 1. Now, next thing I'm going to do is I'm going to draw in my other diagonal. Now, when I draw in my other diagonal, I know it's going to form a right angle. My 60 degree angle is staying put, so again I have a 30, 60, 90. Now my 90 has a 10 across from it. So across from my 90 is 10. Across from my 30 is going to give me 5, which is going to be this piece right here. I don't need that piece. I need the piece that's going to be across from my 60 degree angle, this angle right here. Across from my 30 is 5, across from my 60 is 5 root 3. That diagonal of my kite was being bisected. So if one half is 5 root 3, the other half is 5 root 3. So my diagonal 2 is going to be 10 root 3. So we have a 10 root 3 diagonal and a 20 diagonal. The area of my kite, 1/2 diagonal 1 times diagonal 2 is going to end up giving me 100 root 3. Now, I need to find the area of my sector. So I'm going to erase the stuff I have in the middle here. For the area of my sector, what I know that I have, again, is I have a central angle, and my central angle was 120 degrees. To find the area of my sector, I'm going to do my arc measure over 360 times the area of my circle, radius squared pi, which means that I have 1/3 of 100 pi, which is 33 1/3 pi. Now, the area of my shaded region is going to end up giving me 100 square root 3 minus 33 1/3 pi. And that's what we got. Okay, 2 more examples to go. Let's do this one together. The area of the shaded region. Our game plan is we're going to find the area of the rectangle, and we're going to subtract out those 3 circles areas. So here we go. What we have here is we have a total distance that we're spanning here of 12, which is going to include 3 circles. 3 circles that are touching at just one point, which means that the diameter of these circles is going to be diameters of 4. Now, if my diameter is 4, that means that my radius is going to be 2. Now, all radii are congruent. That being said, we actually know what the height of my rectangle is going to be. It's going to be 4. So area of my rectangle, base times height, is going to give me 48. Now, the area of each circle, and there's 3 of them, is going to be radius squared pi. So 3 sets of 4 pi gives me a total of 12 pi. The area of my shaded region is 48 minus 12 pi. So here's our last example that we're going to do together. We want to again try and find the area of that shaded region. Now, come up with a game plan and let's see what we got. Hopefully your game plan is we're going to find the area of the circle and we're going to subtract out the area of that regular hexagon. I counted that it had 6 sides. So here we go. First thing is to find the area of the circle, we need the radius of the circle. So what I want to do in here is I want to try and build in a triangle. When I build in that triangle, I'm using the corners, which aren't going to be used for the area of the hexagon, but it is going to be the radius of my circle. Now I'm going to try and figure this out. Now, what I know here is that my hexagon had 120-degree angles, and when the radius came through, it split it into 60 and 60, which means there's 60 degrees left for my central angle, which also means my arc is also going to be 60 degrees as well. Now, an equiangular triangle is also going to be an equilateral triangle. So we know that my radius is 10, so the area of my circle, radius squared pi, is going to give me 100 pi. Now, the area of that hexagon. For the area of the hexagon, what I need to try and find out is what my apothem is, which is unknown, and what my perimeter is. Now, all I need is that apothem. I know my radius is 10, I knew my sides were 10, so it's split into 5 and 5. Now, 60 degrees in the corner. If across from my 30 was my 5, across from my 60 is 5 or 3. Area of the hexagon is 1/2 the perimeter. We have 6 sides of 10, so 60, times my apothem, 5 or 3. Half of 60 is 30. 30 times 5 root 3 is 150 root 3. So the area of my shaded region is going to be 100 pi minus 150 square root 3. So here's our homework answers to our homework. All we're going to have is 6 problems that we're going to do. Now, just be kind of careful right here. What I have is problem number 14. Because the answers were so long, it actually ran into 2 lines. So problem number 14, its answers filled into the second line. So just kind of be careful right here when you're reading the answers. If you have any questions, feel free to ask me. And as always, have a good one.